All right, so potential energy practice problems. Very easy. This is actually easier than kinetic energy practice problems, so that you're in luck. You only got to do 1 through 5 because the rest is a lab kind of deal and another lab, right? So that's pretty easy, pretty straightforward. So first things first, what's my formula for potential energy? Potential energy equals mass, gravity, height. Of course, this is formula for gravitational potential energy, right? So that's good news because we already know that gravity is 9.8 from the gravity unit, so this will be easy. So let's do number 1. Potential energy equals mass, gravity, height. A man with a mass of 80 is standing on a table that is 1.5 meters above the ground. What is his potential energy? Okay. Oh my gosh, they only gave us 2 things, but we need all 4. Well, we already know this, remember? That's easy. Gravity equals 9.8. So we already got that. Potential energy equals mass, 80, times 9.8, times 1.5. This is plug and chug, baby. This is easy. Put it all in the calculator, make money. We should get 1176. We know it's in joules because it is energy. And that's it. Right? Pretty straightforward. Hopefully that was easy. It's plug and chug. This is all straight like Algebra 1 stuff. High jumper clears the vertical distance of blah blah blah. So our height equals 2.45. Our potential energy equals 1.59 times 10 to the 3. What's his mass? Mass equals question mark. I don't know it. What is that mass? So let's set it up. So 1.59. Actually, I'm going to convert it. So times 10 to the 3. 1, 2, add a 0. 1590 equals, we don't know mass, we know gravity, and we know height. Because it says what was his mass at the top of this height, right? Technically, it doesn't matter where, how high he is, his mass isn't going to change, but it would change his potential energy. So that's why they just want to be specific. It's at the top of his jump. This is what his potential energy was. What's his mass, right? So here's all we got to do for this one. We do this times this, and then we take that number and we divide it over. Right? Easy money. So you should get 66.22 kilograms. I know that's kind of sloppy, but there it is. So again, mass times gravity times height. This times this. You take your number, and then you divide that number over. Divide that number over. It doesn't get much straightforward than that, guys. Very easy. It's very easy stuff. Okay, a city is situated. I see 3 numbers, so we got to really make sure we're doing it right. A city is situated 4,080 meters above sea level. A car with a mass of 905 kilograms is driven from a location that is 1,860 meters above sea level. What is the increase in potential energy? Okay, so here's the city. Here's the guy in the car, right? They drive from this height all the way up to here. So it looks like they drive higher. So he's on this little piece of land. Oh, that is such a bad drawing. All right, scratch that. He's on this road. He's got to go up to this city on this road. This road is 1860 meters above sea level. Up here is 4080 meters above sea level, right? So it looks like he increased his height above sea level, right? We already know his mass. His mass ain't going to change. What is his increase in potential energy? So first off, we don't know the potential energy. So we're going to go potential energy equals Mass, not going to change, 905. Gravity, not going to change, 9.8. This is where we got to get it right. Hopefully you guys got this right away. Some of you might eventually got it, and some of you might be like, do I use this number or this number? I don't know. All right, so we don't use either of these numbers, right? They want to know the increase in potential energy. So as he went up, what's increased? So if I was like, if you have $10 and all of a sudden you have $50, your increase is $40, right? Because you started with 10 and you ended with 50, right? So same concept. If you started here and you ended here, the difference is how much you increased. So in this case, it is 2,220, I believe. So hopefully you guys got that. It's the increase in potential energy. So this times this times this, obviously it's going to be a very big number. Potential energy equals 19689180. It's energy, so it's joules. And there you go. So it's a pretty big increase, right? Yeah. So pay attention, guys. Sometimes when we rush on these things, we just write numbers down because it's like, oh, that's easy. Because you get overconfident, a little bit arrogant. You know, it's fun to be arrogant, but it sucks when you get stuff wrong because you're like, oh, I thought it was easy, so I just hurry up and write stuff down, then I skip stuff. So don't be in a rush and not analyze and just be like, it's this one. Or it's this one. Because really it's neither one of these, right? It's the difference. So keep that in mind. All right, number 4. So a rock has 2 kilograms. It's nudged off the edge of that. At some point during the fall, it's lost 250 joules of energy. At what height does that occur? So it's lost 250 joules. So we need to know the height. So potential energy equals mass, gravity, height. So we don't have the height because it says at what height, right? So it obviously ain't 20. So our potential energy, we're going to put 250 because that's how much it has left. Mass is the same, 2, 9.8, and height we don't know. Okay, well, let's multiply these two together, which is 19.6, and you're going to divide that into this, and you should get, and then you should get a height of 12.75. So that's not the answer though, right? So why did I circle it? I don't know. Habit, I guess. So 12.75, that is 250 joules. That's how much energy it would have had. So we want to know at what point did it lose 250 joules. So we're going to do the height of 20, and we're going to subtract, why did I do equal sign? I'm zoning out. 12.75, and we should get 7.24 meters. So at this point, it's lost 250 joules. Right? Yeah. So let's recap this, just for those of you who are wanting to understand. It's very hard to just be like, oh, it has to fall this many feet to figure out it's lost 250 joules. But we can figure out the height this mass object would need to fall in order to equal 250 joules. And once we figure that height out, we just subtract it from this, and that's how many meters it would need to fall in order to lose that much. Hopefully that makes sense. If not, rewind it a whole bunch of times till it does. All right, number 5. Last one. A spring for, okay, now we're getting to a little bit different one. Now we're getting to potential energy, but at like spring potential energy, right? Like when you stretch a rubber band, that's not gravitational potential energy, because that's like spring, right? Or when you stretch a spring. So, force constant of 5.2. Force constant is K, 5.2. And it has a relaxed length of that, when a mass is attached to the end of the spring and allowed to come to a rest, the vertical length of the spring is that. Calculate the elastic potential energy. So, the elastic potential energy formula equals 1/2 times the force constant, which is K, times X, which is actually like amount compressed or stretched squared. Hopefully that makes sense, right? So, elastic potential energy. Let's pull it up because I actually have a formula chart somewhere over here. Let's see. So here we go. Elastic potential energy. Right here. 1/2 spring constant, distance stretched or compressed. In this case, it's going to be stretched, right? Relaxed length. Yeah, it's stretched. So, potential energy equals 1/2 times 5.2 times, I'm going to write it all in. Actually, no, I'm not. Whatever, I guess I will. Now, we're going to do amount stretched, because that's what it is, because it's relaxed here and it stretches to here. So we can figure out how much it stretched by going 3.57 minus 2.45. So that's the amount stretched, and then that's going to be squared. So you can do this first and then put the number in here squared, or you can just put it in like this, whatever. So our elastic potential energy should equal 3.26 joules because it's energy. So notice it's still joules. 3.26 joules. Alright guys, that's it. Pretty straightforward, pretty easy. If you guys got any questions, let me know. Holla.